In this video we have the integral of sine to the fifth of 3x, and we want to evaluate this integral. Now we have an odd power of sine here, so we could factor out one of the signs, and this would be then sine squared, or sine to the fourth I should say, of 3x, and then I have the sine over here. So I focus on this right here. I know the derivative of cosine is minus sine. Don't have a cosine over here. But I can break up this sine to the fourth, and I have the identity, of course, that cosine squared of an angle plus the sine squared of that same angle is equal to 1. In our case, the angle is 3x. I could have 3x here and 3x here. That's going to equal to 1. So if I can solve, or solving for sine squared here, I can get that in terms of cosine. So what I'm going to look at is this. Let's say the integral, and this right here, sine to the fourth, can be written as the square of sine squared. Okay, sine squared here, taken to the second power, gives me sine to the fourth. So solving for sine squared, taking this over, then I can replace the sine squared of 3x by minus, or 1 minus, I should say, the cosine squared of 3x. And then I still have the sine of 3x dx. So I'm going to let u equal to cosine of 3x. Then du would equal to the derivative of cosine is minus sine of 3x. And then it's the dx. And using the chain rule in reverse, I have to multiply, or using the chain rule I should say, multiply by the derivative of 3x, which is 3, so this will come out here. Okay? And then I'm going to solve for this. So I'm going to divide both sides by -3, make it a positive 1 over here, and with a minus there over 3. Then I can transform this and go into one involving the variable u. The next step here then would be integral of, and then it's 1 minus, and then cosine, remember, is u. So this cosine squared of 3x here, I can replace that by u squared. That's in here. But then I still have a square outside this parenthesis, so then I have a square right there. And then this part right here, the sine x of dx over here, sine x of 3x dx is minus du. So this will be du. And then the minus 1/3, I can put it right here in front of the parentheses, so I can take it outside the integral and write it out here. I got that. And then just square this out. So it's the integral of squaring this. This will give me a 1 minus 2u squared, double that product there. Then it's plus the u squared, which is u to the fourth. This will be du. So we haven't integrated yet. We're doing the algebra here. Now we can multiply through then, or have the negative 1/3 here still. And then we integrate term by term, just like we had 3 integrals here with respect to u. 1 integrated with respect to u is u. The next one, add 1 to the 2, this will give me a 3 there. Basic integration. And I get the 2/3 here. And then it's plus, add 1 to the 4, we get u to the fifth over 5. And then we have plus the constant of integration. So we have the integration now. All we have to do now is go back to the original variable. So wherever we have a u, replace it by cosine of 3x. So for the first u here, we have cosine of 3x. And then we have the minus 1/3 multiplying each of these. So I'll put a minus there, and this is over 3. And for the next one, multiply by minus 1/3, so I'll make that a plus, so this will be a plus, and there will be 2/9 here. And the u is cosine of 3x, and this is an exponent of 3. Now we could put parentheses on here, just to make it more clear. And then for the next one, we're multiplying by minus 1/3, so u to the fifth over 5 multiplied by negative 1/3, and then we place also the u by cosine of 3x, so this will be then a minus 1 over 15. I could put the 15 under here, under the denominator, and this will be cosine to the 5th power of 3x, and plus the constant of integration. So we get minus cosine of 3x over 3 plus 2/9 of cosine of to the 3rd 3x minus cosine to the 5th of 3x over 15 plus the constant of integration.